Module 5, Week 3, Dust, Adverse Effects on Human Health. What is dust? Dust consists of solid particles ranging in size from less than 1 micrometer up to approximately 100 micrometers. Presence of dust can be recognized by low visibility of the air. When people inhale airborne dust day after day, year after year at work or outside, they're at risk of respiratory disease. Overexposure to dust causes temporary and permanent disabilities and sometimes death. Dust in the workplace may also contaminate or reduce the quality of products, cause fires and explosions, and damage the environment. Let's consider the composition of the Earth's atmosphere. On the diagrams at the right, you see that Earth's atmosphere consists of 78% nitrogen, almost 21% oxygen, and 1% other gases. Why so much nitrogen? After Earth accretion, many elements have formed rocks or part of the liquid and solid core. Gases such as oxygen and hydrogen have also been chemically bonded, forming water. Others, mostly light elements, were released into the atmosphere. Nitrogen is one of them. It is very stable, does not bind well with other elements. It was concentrated in the atmosphere. Now part of nitrogen is actively cycling between the biosphere and the shallow Earth, mostly ocean, soils, and sediments. You may have the impression that the concentration of oxygen is lower at the mountains, and therefore people have difficulties breathing. This is not true. The concentration of oxygen in the atmosphere is the same around the globe. However, people have difficulties breathing at higher elevations because the air there is less compressed. The thinner air at higher elevations mean that in given volume of air has fewer molecules present. This is what causes the feeling that there is not enough oxygen to breathe. Compare the pressure of the air at sea level and at the elevation of Mount Everest. Everest is the highest mountain on the Earth, 8,848 kilometers. This is what causes the feeling that there is not enough oxygen to breathe. Smog, dust, and air pollution. When we see smog or dusty wind obscuring blue sky, we express our concern about air pollution. How should we define if the air is badly polluted? This is Palm Springs, California. You see two examples of the same area. On the left, the blue sky above the wind turbines, and on the right, after a dust storm. You hardly recognize the wind turbines and the sky is no longer blue. Though dust and air pollution are very close to each other, they belong to different scientific categories. For this reason, we will consider them separately. Dust. Definitions and concepts. Dust are solid particles ranging in size from less than 1 micrometer up to 100 micrometers. They may have different compositions, shape, and may be airborne. The latter depends on their origin, physical characteristics, and ambient conditions. Examples of toxic dusts. Mineral dusts include such as free crystalline silica, particles of any other toxic minerals, coal and cement dusts. Metallic dusts, including minerals such as lead, cadmium, nickel, and beryllium. Other chemical dusts may include chemicals and pesticides. Other examples of toxic dusts include organic and vegetable dusts such as flour, wood, cotton, tea dust, and pollens. Biohazards include viable particles, molds, and spores. Fibrous dust can contain needle-like particles of asbestos, minerals, synthetic fibrous materials such as glass, wool, ceramic, aramid, nylon, carbon, and silicon carbide fibers. Particulate matter is a mixture of solid particles and liquid droplets found in the air. Some particles, such as mineral, metallic, and other types of dust, dirt, soot, or smoke, are large or dark enough to be seen with the naked eye. Smaller particles can be detected with the aid of an optical and electron microscopes. PM 2.5, fine inhalable particles, with diameters that are generally 2.5 micrometers and smaller. Any dust, combustion particles, organic compounds, etc. PN10, inhalable particles with diameters that are generally 10 micrometers and smaller. Any dust, pollen, mold. See comparison of their sizes with a human hair. PM 2.5 micrometers and below pose the biggest threat to human health. Primary particles. They emit directly to air from their source. Construction sites, roads, freeways, sand dust, weathered rocks and soils from agricultural fields, volcanic eruptions, tornadoes, fires, etc. Secondary particles. They form in the atmosphere from chemical elements and compounds. Carbon, hydrogen, sulfur, nitrogen, oxygen, ozone, sulfur dioxide, nitrogen oxide, methane, carbon oxide, carbon dioxide, and others. Their composition varies depending on the time of year, amount of vehicle exhaust, smoke of burning wood and coal, and industrial deposition of different particulate matter in the human body. The large particles, more than 5, precipitate in the nasal cavity and throat, whereas the smaller particulate matter, 1 to 5, precipitate in the upper part of lungs, and the smallest particulate matter, less than 1, moves down to the lower part of the lungs. What are the harmful effects of particulate matter? Airborne dusts are of particular concern because they cause occupational lung diseases such as pneumoconiosis, silicosis, as well as lead and other metallic dusts, poisoning, especially at higher levels of exposure. But in the modern era, there is also increasing interest in other dust-related diseases, such as cancer, asthma, allergic alveolitis, as well as other whole range of non-respiratory illnesses, which may occur at much lower exposure levels. The lifetime of dust particles in the atmosphere is in the order from minutes to days, weeks, and years, depending on their size. This table shows that smaller particles remain in the atmosphere for about 228 years if their size is 0.2 microns. The larger particles have a shorter lifetime, 1.8 minutes, if their size is 5,000 microns. Now prepare for a quiz.